Let's be honest. Building a forecasting model is frequently a mess. We spend most of our time scrubbing data and fixing errors before we even get to the math, i.e. the fun part. The problem isn't just picking a fancy equation. It's that real-world data is noisy and messy. Right now we have these black box models that give you a number but don't tell you why, or they break the moment the pattern changes. We don't just need a calculator here, we need a scientist, and people behind Gen AI have been promising exactly that. We need something that looks at the data, thinks about it, cleans it up, and then decides what to do. That's what this paper tries to build, an automated scientist. Take a look at this structure. It's kinda neat because it mimics how a real research team works. You don't just have one giant brain doing everything. You have 4 distinct roles. First, on the left, you have the curator. Think of them as the careful lab assistant who checks the glassware. They find the outliers and fix the missing data. Then you have the planner. They look at the clean data and say, aha, this looks seasonal, let's use these specific tools. Then the forecaster actually runs the experiments and combines the results. Finally, the reporter writes it all down so we can understand it. Long story short, it's a chain of reasoning. Let's dig into the machinery. The curator isn't just deleting bad data. It's using an LLM to reason about why a point is weird and fixing it intelligently. Then the planner steps in. It doesn't blindly try every model in existence. It looks at the charts, literally looks at the visual patterns, and narrows down the list. If it sees a wave, it picks a model that understands waves. The forecaster then takes the best options and mixes them together, ensembles them, to get a stable answer. And the reporter? It translates all that math back into English so a human can trust it. This is what comes out the other end. 9 out of 10 times, the models produce a point forecast. But that's useless if you don't know the confidence interval or the assumptions behind it. This report is like a lab notebook. It shows you the forecast, but it also shows the confidence bands, those shaded areas telling you how sure it is. It explains the rationale. I chose this model because the data has a strong weekly cycle. It lists the limitations. It turns the prediction into a conversation between the machine and the human, making the whole process transparent. Now, does it actually work? They put this system against the heavy hitters, GPT-4 on its own, and the classic statistical methods we've used for decades. They ran it on electricity data, weather, traffic, real messy stuff. The interesting thing they found is that if you take away the curator, the cleaning part, the performance falls apart. It turns out, preparing the ingredients is just as important as the cooking. Kinda obvious to anyone who's spent meaningful time actually building forecasting solutions, but still nice to see it confirmed. The system consistently beat the other methods, especially when predicting for longer horizons, because it was planning. Look at the numbers here. We aren't talking about a 1% improvement. We're seeing a massive drop in error, over 30% compared to just asking a standard LLM to guess the next number. The red numbers in the table show where TimeSeriesScientist wins, and it's winning almost everywhere. Why? Because the base LLMs, like GPT-4, are smart, but they aren't specialists. They try to do it all in one go. TimeSeriesScientist breaks the problem down. It beats the specialists at their own game by being disciplined about the process. So, what have we learned? We learned that if you want to solve a hard problem like forecasting, you don't just need a bigger brain, you need a better process. TimeSeriesScientist proves that by using agents to act like a team of scientists, you get better results, and crucially, you understand why you got those results. It turns a black box into a glass box. It's a step toward AI that doesn't just compute, but actually conducts science,